Everyone, if you're new to the channel, you can subscribe to the channel for future updates. And guys, please visit my website, guys. You can check the link in the description below. And of course, I have launched the new Instagram account and make sure you follow for more future updates. Enjoy the solutions.
Hello everyone, welcome to this Gakubu Physics 2016 part 5. And there's an optics question there. Okay, so as shown in the figure there, rectangular glass blocks with an index of refraction of n2 are attached to the upper and lower planes of the rectangular glass block with an index of diffraction of n1. A light ray enters the glass block at point A from the vacuum in the incident angle of theta. The light ray reaches point B after repeating the total internal reflection in the block. The speed of light in the vacuum is denoted as c, and answer the following question. So basically for this question is about optics, so let me draw. So basically what this says that the light, okay, comes from the air, right? And then it is refracted into the glass block with an index of refraction of n1, but the glass block outside, the upper and the lower part is n2. Okay, so the light come with the incident angle of theta, then it is entered to the glass block with the index of refraction of phi. Okay, and the light in the glass block is internally reflected until it reaches point B. So basically this question is about optics. So for number 1, it is said an angle of refraction of light ray entered at point A is denoted as phi. Find the correct expression for sine phi. And you know that the formula for this is called the Snell's law, right? So the Snell's law said that the angle of refraction from the incident of light times the sine of the angle itself equals the index of refraction of the refracted light times sine of the refracted angle. Now in this case, it is come from the vacuum. Remember that light coming from the vacuum, the index of refraction is 1, okay? It is coming with this incident angle of theta, and the index of refraction of the refracted light is n1, and the angle of refraction is denoted as phi. So now we got the correct expression of sine phi is sine theta over n1. Okay, so the answer is C. Now for number 2, find the condition that n1 and n2 should satisfy in order that total internal reflection take place in the upper and lower planes of the glass block. They ask us what is the relation between n1 and n2 so that the internal reflection of this light can occur. Okay, so basically when you have the total internal reflection, right, so this is the difference. The light coming from the vacuum to the glass block is reflected, right? But the light from the inside of the rectangular glass block to the lower part of this glass block, it is not refracted, but it is internally reflected. So basically, there is no refracted light that coming out of here. So because we cannot, use the Snell's law, let us assume that this that the angle of the reflected is, let's say that is 90 degrees. Okay, so n1, I just make the Snell's law here, and the angle of the incident coming from inside, the index of refraction is n1, and now the incident angle is actually, this is phi, is actually 90 minus phi. Okay, so sine 90 minus phi, and the light that want to go is the light wanted to go to the outer part of the glass block, which is n2, and now we have no any refracted angle. Okay, the biggest angle that could happen, the biggest refracted angle is only 90, right? So let's just assume that it's 90, but actually there's no refracted light. Okay, and if you ask what happened when the refracted angle is 90, actually it is actually also the case that when you have a light here coming there, the refracted angle is this way. Really, it's 90 degrees. That is called the critical angle. But the case where the total internal reflection angle could happen is where this incident angle, internal refraction of the incident, is greater than the critical angle. Okay, so let's just assume that we have this 90 because there's no refracted angle in total internal reflection. So this n1 cosine phi is equal to n2. Okay, so n1 over n2 is 1 minus cosine phi. And now you see that this cosine phi, if the value of the cosine phi is actually, the result of this is must be greater than 1, right? So n1 over n2 is greater than 1. Okay, so that is for number 2. And now let's look for number 3. Now number 3 is asked, find the condition that phi should satisfy so that the total internal reflection can happen too. So what is the condition for the phi so that it could happen? And now you see that the angle of the incident here we have is 90 over phi, right? So n1 sine 90 minus phi equals n2. Now let's just assume that is also 90 degrees. Okay, now this is actually for the critical angle, right? So this is n1 cosine phi equals n2. Okay, so cosine phi equals n2 over n1. Okay, so this is what I mean. When you have a light, okay, coming here, if the refracted angle is 90 degrees, the angle of the incident is called the critical angle. For the internal reflection could happen, this angle should be bigger, so that is called the internal reflection angle. Okay, so that is what happened after that. Okay, so that way, this is cosine alpha is equal n2 over n1 because the angle that coming from that is incident is called the critical angle. So that the internal reflection could happen, the angle should be bigger than this critical angle. Okay, so the cosine phi must be bigger than the result of this, right? So the answer is option E. Okay, so you got it, that we assume that it's 90 degrees, right? And we assume that this is a critical angle. But for the internal reflection could happen, this angle should be bigger, right? Therefore, it is greater than n2 divided by n1. Okay, so number 4 now. Find the time at which the light entering at point A reaches point B penetrating through the glass block. The distance between the two planes including points A and B is denoted as L. So what this number means that the question means we have to find the time when the light comes from here, then there, and there. What is the time? Okay, the general formula of time is distance over velocity. The distance is L, right? From the picture, L. And for the V, for light, actually the index of refraction is equal to the velocity of light over the velocity of light in the medium, right? So the velocity is c over n1. And now you see when the light come here, when the light inside here is going that way, right? Light is going that way, so that the light is we assume that it's going straight. So this is V, so this is V cosine phi. Okay, so that is L over C over N1 cos phi. So that is L and 1 c cos phi. Okay, so that the answer is A. Okay, so that is everyone for Physics 2016 Part 5. And yeah, stay tuned for other video solutions.